Hello everybody, it's Mike Levin. Monday, August 15th at around 8:30 a.m. Running a little late and I have to drop something off this morning. So I figured I'd start my video on my walk through the center court here at Park Terrace Gardens, something I should probably do more often considering the how beautiful it's landscaped here, and it's nice to give people a view of it on the walk. So, probably it would be better during spring to see everything in bloom. Well, anyway, I talk a lot about coding, and I started listening to Richard Feynman over the weekend a bit because I had a little time and I love YouTubing, and it's one of the things that keeps getting auto-suggest based on my other viewing habits such as Michio Kaku and Dawkins. And so I said, okay, yeah, everyone says he's the great educator in particle physics. So I decided to listen to a few of his legendary lectures. That's always been on my to-do list, and wow, he really does make things accessible. Now I have a feeling all this video that's on YouTube is really sort of the preamble to when he's doing chalk on the blackboard, because it's so accessible and lays such a wonderful foundation and framework for the stuff he's going to talk about, that you feel like you don't have to get hung up on actually understanding the meaning. He actually, on one of his lectures, he goes out of his way to make the point that a lot of people sort of give up and fail at this stuff because they spend too much time trying to imagine and to relate what this math means to things that they know in the real world. And Feynman makes the point over and over that once you get down to a certain scale in the physical world, things just stop making intuitive sense. The more complex they get, the more you have to rely on pure statistics and have to actually believe things like a particle being able to be in two places at once. And I watched a whole bunch of pieces from Feynman, not just the lectures, but like him being interviewed with the guy saying when you put two magnets together, same to same pole, and they repel, what is that in between there? And at first Feynman sort of like gives one of those flippant answers of the super intellectual that is always the fear when trying to learn from one of these uber brains. And then he quickly sort of flows right into why he gives that flippant answer. And it boils down to the fact that when you want to understand our world, you have to start with the mysterious invisible forces that just happen to be a little more visible with magnets because of quantity, scale. The number of atoms that are aligned in such and such a way in a piece of magnetic iron makes effects visible at a distance much more dramatically than other things in our everyday experience, like a hand's not being able to pass through the arm of a chair. But then he gives additional examples of when you brush your hair and you get the static electricity, and electrons run from one side to the other, throwing off the normally stable balance where all the very strong energies in our universe counterbalance each other at a very small and dispersed scale, so you don't feel the magnetism so much, but it's there. And you have to just learn to accept the fact that things that defy our common everyday experiences may actually be the more true real world than the one that we kind of experience and put together, the much more I guess particle part of the particle wave theory stuff in our heads. You know, objects can't pass through each other. A rock is mostly material, whereas the particle physicist would say the rock is mostly empty space. And all kinds of suspensions of disbelief are required when figuring out how the world works, especially at the very small scale. As you get to the very large scale and more Newtonian physics, things start to make much more intuitive sense. And there's always these recurring patterns that are quite interesting. At the large scale, things tend to flatten out into planes, such as the way our solar system has an orbital plane and the galaxy has an orbital plane, and how you get a spiraling effect naturally because of the way orbital velocities work. The closer they are to the center, the faster they go. The further out they go, the slower they go. And that's where you get things like the shape of the spiral galaxies. And so on through generalities. Some of these generalities surviving the transition from the very large cosmic galactic universe scale down to the subatomic particle scale. Some survive and some don't. Some work totally different. This is why whenever, you know, a student in school first realizes that the shape that's being constructed of electrons spinning around a proton is approximately the same shape being constructed by planets spinning around a sun, the human brain sees that same pattern and goes, aha, well, there's something fundamental and cosmic. I wonder if anyone else ever noticed this. And then they get the answer eventually that yes, it's noticed, and while there are similarities, when you start drilling down on the details of what's really going on there, they are in fact very different. But, you know, there's useful takeaways there. Things orbit things. Gravity or attraction seems to always be something in play, and then attraction becomes repulsion after a certain point, and that things balance out somewhere in the middle. In the case of planets orbiting a star, that balancing out is something being in perpetual free fall in towards the center, but because it has a angular velocity away from the thing in the center, it's always falling away, always falling downwards, but always still falling away. So that's how things get locked into that seemingly stable long-term orbit in space, which is not as stable in long-term as it might seem, because, you know, unless it's perfectly balanced, and I don't even know if there is such a thing, things are going to escape and fly off, or they're going to eventually spiral in towards the center. And in the case of, you know, the cosmic level, a thing in the center, probably sun, is probably going to be burning up its fuel and going one of two ways: burning out in a giant red, you know, dissipation of energy as it gets bigger, or get smaller and smaller and smaller till it explodes and then has a second stage sun. And the explosion is going to leave stuff around it that might start orbiting and become the planet. So it's a really wonderful system rigged to produce the conditions in which life could arise. So you got to think about that at the cosmic level. Things are really arranged so that, you know, it's a planet producing factory. Down at the much tinier level, things start to look a lot more like pure information. Information that can pop in and out of existence, information that can have multiple states, at least three, in one place, in another place, or in an unknown state. So as these things often go, whenever we want to try and find, you know, binary in things, we find, I guess it's trinary. You know, even in common digital electronics, there's often something like an empty or a null or a not yet set state. So if something has never been initialized, never set, that's kind of its own separate state. Then you can throw it to a 0 state or a 1 state. But you know, the often making things work in reality truth is that binary is never binary. There's at least a third dimension or state involved. Like just look at Morse code. Dots and dashes, well, the spaces in between have meaning too. So the world always gets a little bit more complex and rich than at first is suspected, and that's what we're finding down on the tiny scale. And so my priority, gosh, it's loud out there. I think I'm going to take this other route so I can finish out this thought. And so the important thing here is that all these sciences are finally being drawn together in one possibly grand unified theory of everything. And it might actually have been achieved with these superstring and symmetry theories sort of combining together. Without experimentation, the world of theoretical particle physics is showing us that this set of rules, this way that the universe might work, could actually be it, and we could actually have the theory of everything. Or we could have one of an infinite variety of theories of everything that could be equally valid until we can experimentally verify. And so we are in the age of experimental verification of the theories of everything. And that's a pretty exciting time to be in humankind, because, you know, no matter what anyone says about the earth and us being the stewards of the earth, being irresponsible and pushing it beyond a tipping point of no return, I reject that. I think that the rate at which science and knowledge and human capabilities is advancing just simply puts us in a state where there's certain races going on, and as long as the crossover occurs in the correct direction, we have sort of banked the human race's ability to exist. And short of a couple of really long shots like a gamma burst that we don't know is coming, for which we could have never prepared ourselves, because there's no getting us off the planet far enough to protect us from that kind of event. But anything shy of a gamma ray burst, we can pretty much save ourselves. If it's an asteroid hit, we can have colonies off planet. We're not so far gone that we can't do a little scattering diaspora stuff before some cataclysm hits. And likewise, the man-made stuff or the human-made stuff, we've got to refine our language now for the better. And hopefully we're at the very beginning of much for the better, but that's a whole nother discussion. I'm so glad Addie is around at the time in history when she is. She is living one of mankind's largest pushes forward ever. Sure, there's been, a times 10 population explosion over the past few hundred years, but one of the outcomes of that is more invention, more delving into every idea, every possibility, and much more parallelism in figuring out what it's all about. And the first few layers peeled away. The first few layers peeled away by some of the great, unusual minds on this planet. Maybe not so unusual. Maybe the whole trick is just seeding the world with enough activities, enticing lower grade educational entertainment activities to spark off that wonder and that imagination. Certainly I see it's being done in cartoons with all this stuff about portals. Star Butterfly has these scissors that you just snip away and pass through dimensions. And I have discussions all the time about you know, whether the fourth spatial dimension is time or space, and if it's space, that portal thing they're doing is actually one interpretation of how you might pop between these different spatial dimensions. And she's 5.5 years old. Wow. I'm not gonna like push her to be a scientist or an inventor, but oh my goodness, is it the time for that kind of stuff, because that second layer is being peeled away, on the verge of being peeled away, might already have been peeled away. Scientific experimentation is going to show one way or the other. And then there's all the derivative stuff, the biological sciences, and you know, the improving life and happiness and the quality of life for, you know, billions of people. Dealing with the issues surrounding population explosion, how to turn a negative into a positive. It can very well be a positive. I read just enough sci-fi to believe that this might push us into whatever, you know, cities that float on the surface of the ocean, having neutral impact, and space elevators. There's a whole bunch of stuff. Well, anyway, I got to wrap this up because I got to get into work, but that was a fun one. You know, have a little optimism, people. You know, we're human beings, and the fact that we could do as much as we have on this planet, to this planet, in a few hundred years, or less if you count from the Industrial Revolution, we can do great positive things now that we kind of are just getting the bandwagon, the crazy technology bandwagon that we jumped onto, under control. Steer it, rein it in a little bit, be a little more deliberate about it, and then splinter off separate copies of that bandwagon. And very important projects going on. And watching Richard Feynman over the weekend just really reminded me how amazingly large of a difference single individuals can do. You know, forget the fact that there's 7 billion of us on the planet and you're in competition with every one of them. A unique new idea is unique and new, even if other people had it. If you're the person who recognizes its importance, moves forward on it, and acts on it, and plenty of room for, you know, making everything better for everyone, Tikkun Olam and all that stuff. Anyway, thanks for joining me. Hope to talk to you again soon, and don't forget to subscribe.